I'm going to blow this topology off. You guys need to pay attention to this. This is important. And if you don't pay attention, you might get confused. So I have 1, router 2, router 3, 4, and 5. Router 1 to 2, 2 to 3, serial link over here, serial link over here. I'll put addresses over here as well, so you guys can follow along. This address over here is 10.12.12.0. This address over here is 10.23.23.0. Or actually, because I'm going to be running this in VRF, so I'll say 10.10, 10.10. I have two 10.2s over here. Let me finish the thing, and then I'll explain it. And guys, if you're here and there, just focus, because this is very important what is coming up right now. I'm going to set this topology up so it becomes important for the rest of the two labs to understand the topology. Okay. Now, what I'm going to be doing over here is I am going to be putting this interface in the red VRF. I'm going to put these two interfaces in the blue VRF. Okay? The blue VRF 10.11 and 10.22 should be able to talk to each other. The red VRF 10.11 and 10.22 should be able to talk to each other. Good so far? Let's do that part first. And I do want your interaction in this particular lab, because I want to make sure you guys are following along and understanding it. No VPN, just VRFs. Okay? Help me do this. What would I do on R1 right now? R1 does not need to have a VRF because it's its own entity, right? No conflicts over there. So let's start with R1. Loopback 0, we said was 10.1.1.1. F00, 10.10.10.1. IP route 10.2.2.0 through 10.10.10.2. Actually, I can, yeah, that's okay. For right now, this is good enough. We will do that in here, yes. Done? Now R2. R2, I'll have two VRFs. I'll have IPVRF cost A, IPVRF cost B. A is towards R1, so interface F0/0, IPVRF forwarding cost A, IP address 10.10.10.2. Okay, no shut, interface loopback 0, IPVRF forwarding cost A 10.2.2.2. Notice I created the VRF inside the interface inside the loopback interface under the VRF cost A. So if I do a ping, oh, I need to create a route over here. R2 needs to ping R1, right? R2 needs to ping R1, the 10.1.1 network. Can it? Why not, Raza? Have to put the route in VRF cost A. Correct. So what I need to do is I need to create a route on R2 towards R1. How? If I do my normal route, 10.1.1.0, pointed to 10.10.10.1, this would put the route in the global routing table. I need to put the route inside my VRF. This is how you do a static route inside a VRF. So as soon as I do that now, I should be able to ping 10.1.1. If you check your routing table, I have that static route via 10.10.10.1. Good so far? Let's repeat the same thing for 2 to 3, this side. Okay, how would I do that? This is also 10.10.10.2, same address, but on a different interface. IPVRF forwarding, I think I did this already, but doesn't matter. IP address 10.10.10.2, same IP. I'll create a loopback 1, also put the second 10.2 in a different VRF. Good. And an IP route for cost B, 10.1.1.0, which is behind R3, pointed towards 10.10.10.3. 10.3 is not configured yet, but it should be soon. Cost A and cost B. 10.10 is the same, 10.2 is the same, 10.1 is the same. It's just the next hop for 10.1 is 10.10.10.3. So router 3. This one is not aware of any VRF, so it just does it normally. Loopback 0, 10.1.1.1. IP route 10.2.2.0 is through 10.10.10.2. So I should be able to ping 10.1.1. There you go. Good, you guys? Good. Everybody understand the topology so far? Now, where is my VRF right now? I have two VRFs, the red and the blue. They're between R1 and R2 and R2 and R3, two separate VRFs. So what's on the other side towards R4? So 2 to 4 or 4 to 5. That I have not put that interface, the S00 interface, in any VRF. Which interface, which VRF would which routing table would they be in by default? The global routing table, right? Everybody agree with that? GRT, absolutely. Good. So let's configure that routing so that R2 has access all the way to R5. Let's set this networking up in the global routing table, all the way from R2 to R5. So on R2, interface S050, IP address 10.24.24.2. This is normal, and I'll point a default gateway towards R4. On R4, I have two interfaces, 10.24.24.4. Should be able to ping 10.24.4.2. Yep. And I have another interface, which is 10. What was the other one? 45 I did. Should be, what did I call it? 45.45.0. This is 4. And R5 over here is going to be 5 on the same network. And again, for reachability on this global network, I'm just going to put a default gateway pointing towards this guy. So at this point, I should be able to ping 24.4.2. So 2 through 5 is also working in the global table. Good, everybody? I haven't leaked the routes out yet, but I've just connected a global routing side and the VRF routing side. Clear so far? Now, my objective on this particular lab is this. You guys ready? Pay attention. I know it's towards the end, but this is important. What I want to do is I want to do a get VPN setup. Where this is my key server. R1 is a group member to encrypt traffic from 10.1 to 10.2. R2 is a group member to encrypt traffic from 10.2 to 10.1. So I have two VPNs. What's a problem that I have? I could just do a normal VPN over here without a problem, but because my key server happens to be where? On the global side, I need this 10.10.10 network to be able to reach the global side. The global needs to know how to get back to 10.10 over here. Understood? Everybody okay with that? So how do I do it? Just take it one step at a time. Don't try to speed this process up. We'll do it one at a time. We'll start this process by allowing 10.10 reachability to the 10.45 network. How do I do it? On R1, it's a normal route pointing towards his next stop is. His next stop is 10.10.10.2. So on R1, IP route 10.45.45. I'll just point to R5 because that's my key server. So my route goes to whom? to R2. So R2 gets a packet inside the VRF. Now inside my VRF, I need to create a route to send the route towards what? The next hop. Where's the next hop over here? Next hop is exiting and reaching this interface, right? Agree? How do I do that route? Where do I do it? On R2. The route itself needs to be put inside your VRF. For the 10.45.45.5 network, okay, go through S0/0 interface. Yep, this is good. Go through that interface. All right. And 10.24.24.4, but with a global. So point the route towards what? The serial 0/0 interface, which is in the global routing table, but you need to put that global at the end. The next hop is 10.24.24.4. So that's how I take the route, and I create the route where, if you take a look at your routing table now, you will have a route for what? So we're injecting the VRF route into the global table. No, we haven't done that yet. We've injected a route that is in the global table in the VRF. Opposite, yes. We have put a route that is in the global, which exists in the global table. We put it into the VRF. Only customer A right now. Yeah, let's just do one at a time. Okay. Now when a packet comes in from R1 to R2, R2 sees 10.45.45. It says, I need to send it to 10.24.24.4 through the serial 0 global table, sends it to R4. R4 receives it. R4 knows how to reach 10.45.45. It reaches R5. R5 gets it. It now will return the packet for 10.10.10, right? 10.10.10, when it comes in over here, what does it do? It comes in, it has a default gateway pointing towards 10, towards this guy, because he has a default gateway. He does not know about the 10 network, right? So what does he do about it? He will need to create a route pointing towards R2. One mistake, I need to segregate these routes. Otherwise, they would not know how to get to the two different ones. So this one has to be 1020. Otherwise, they would cause a problem. I'll change it later on, but I need to have this particular route that is going across as a separate route. So over here on R4, I'm going to say, if I want to reach 10.10.10.0, point to 24.24.2, not to the VR, just to R2. Okay. Now, once I get it on R2, because of this, R2 receives the packet. He will receive the packet in the global table. He has no idea where 10.10.10 is. So over here in the global table, I'm going to create a route for a route that exists where? In the global table. And the way you do that is just pointing it to the interface. So all I'm saying is if a 10.10.10 comes in, just throw it to F00. He'll take care of it. So that's how you create a route in the global table, pointing it towards what? A particular interface. Because that interface is inside the VRF, it'll pick it up from there. So when you want to send the packet back towards the VRF, you just point to the interface. So right now, if I sit on R1 now, and I do a ping to 1045.45.5, it is now going across all the way to the other side. And we'll repeat the same process on what? On R3, going towards the same 1045.45.5. So how do I do it? First thing I needed to change was the IP over here. Because it's within itself, it was not a problem. But when I go out, I need to have different IPs coming back. So that's why it has to be on the 1020 network. That will cause my routing commands to be changed. And on R2, no for this guy. To ping 10.1.to ping VRF cust. There you go. All right. Now help me out, guys. I need to do the same thing over here. I want 10-20-20 network, 10-20-20, let's say 2 and 3 to be able to reach 10-45-45-0. How would I do it? Help me out one step at a time, guys. What's the first thing that I would do? One step at a time. Come on. So go on R3, create a route 10.45.45.5, point it towards 10.20.22. Agreed? So now R3 can reach R2. What do I need to do on R2? The leaking of the route. How do I do that? IP route VRF cust B serial 0/0, the global interface, the next hop, and the keyword global. Good. So at this point, the packet would go from R2 to R4. R4 will send it to 10.45.45.5. It's directly connected. He'll try to come back to 10.20. Does R4 know about 10.20? IP route 10.20.20.0, 10.24.24.2. So R4 will throw the packet towards R2. Now what do I need to do on R2? Are we actually leaking routes or pointing to global? Well, when you create a route, you are creating a route for a route that existed somewhere else. So you are, in essence, leaking it out. Does R2 global need to know about 10.10? Yes, it does, because when the packet is received, it's received on the global interface. And it would not send the packet back onto the inside interface unless you have a route. So I would go to router 2, to show IP route. This is the global one. I only know about 10.10.10.0, which is on F00. What do I do over here? IP route 10.20.20.0. And what do I tell it? How do I throw it towards the VRF? There you go. You get my point. Now, if I go to router 3, ping 10.45.45.5. What do you know? So now both sides can reach, which is eventually going to be my key server. This is my key server. These are my two GMs. Two separate GMs, two different identity groups. Good. Let's write this down for you guys. Route leaking. I'm just going to focus on R2. On R2, allowing the VRF to communicate to an address reachable via the global GRT, global routing table. Okay, how do I do it? IP route cost A. This is the address that I want to reach. It doesn't have to be a host route. It could be a network or a default gateway for that matter. Serial, in my case, 0/0. The next hop, in my case, 10.24.24.4, and the keyword, global. All right. This is in one VRF, and then I have to do the same thing for the other VRF, and this would remain almost the same. Yeah, it is the same actually. So this creates a route inside the VRF pointing towards what? Towards a network on the global side. And on the global side, eventually my KS, yes, allowing the global to communicate to a VRF. So that's simple, right? IP route in the global 10.10.10.0 and pointed to the interface for the VRF. And I'm done. You understand? So that provided me the reachability. Yeses, please, before I go into get VPN now. Some big question came up. Although I never noticed security version 4, this was pre-configured on routers in the lab. What about NC? Even if it was, if you don't understand that, it can get confusing. If you're not confident about this and you have to troubleshoot it, it becomes a problem. So that's why I'm making sure you understand that. All right. Good. Now let's do the get VPN portion. Now help me out with on the key server. Key server in my case, as we talked about, is what? Right? It is for two different groups. So how would I do it? I'll give it 100, and then I'll add group cost B, and I'll give it a group ID of 200. Okay. Step 1, phase 1. Crypto ISACEMP policy 10 auth pre-share hash MD5 root 2, and what else? Encryption triple des. There's no VRFs over here, right? So normal ISAKMP key, Cisco 123 address, and you font, you can do this for the address. So this is the key for anything coming from 1010 or 1020, because my group members are R1 and R2 in the 1020 network, R2 and R3 on the 1020, sorry, R1, R2 on the 1010 network, R2 and R3 on the 1020 network. So my key is done. Step 2, phase 2. Let's say I want to create 2 different transform sets. Let's call it cast A, ESP triple des, ESP MD5 HMAC, and I'll create another one for SHA. And this will be used by B. Okay. Step 3, IPsec profile. CRIPTO IPsec profile prop A set transform dash set cast A B and B. Good. 4. You guys remember? Access dash list 101 permit IP 10.1.1.0 to 10.2.20. Actually, it's the same ACL, but I want to segregate it because I don't want to keep it the same. Because it's the same ACL, 10.1 to 10.2. Actually, no. It'll be 10.1.0. Yeah, in my case, because there's only 2, so it's okay. But if you had more than that, I could do a different ACL. I could even do 10.1.0.0, 0.255, 10.2.0.0. If I had more networks, because mine is just 2 networks, I'm just doing it like that. Anything from 10.1 to anything from 10.2 is what I'm doing. And then the last one is my configure the GDOI groups. Now I'm going to have 2 groups over here. Crypto GDOI group, let's call it trust A, just a name. Identity number is 100. Server local SA IPsec 10. Profile I want to use as prop A. Match address IPv4 is 101. Address is the same for both of them. And this would be for B. 20, the thing will change to B, and this will change to 102. Everybody okay with this? So I did the same thing. I just have 2 different groups, 2 different ACLs, because I have 2 different sets. This is on the key server. Nothing to do with the VRF, but I have to have that reachability before I get to this point. So I'll copy this and paste it to R5. In case we had 2 different VRS, 1 per on the KS, do we need to specify the VRF under the crypto GDOI? Yes, not in the GDOI, the key at the top. And, oh yeah, and if you had it on the thing also, yes, you would also need to do it on the GDOI, correct. No, there's no crypto map applied on the key server. So you would need to take care of it inside the group configuration itself. Done? So this took care of my key server. How about the devices? So this is the key server. Group member, non-VRF, which is R1 and R3. Crypto, I'll just copy it because the phase 1 remains the same. Cisco 123, and my address is 10.45.45.5. This is step 1, which is phase 1. Step 2 is configure the GDI group, crypto GDOI group, ABC, whatever you want to call it. Identity number is 100. Server address is IPv4. Done. Step 3. Configure the crypto map. Crypto map ABC GDOI set group ABC. And the last thing, apply it to the crypto map. Oh, sorry, apply it to the interface. In our case, the interface was Z00 crypto map. I call it ABC. So this should be the config on R1. Oops. Yep. Crypto map 10. And then it should be okay. Notice my registration is complete to 10.45.45.5 for group ABC. Now over here, I am going to go back for R3 and change it a bit, not too much, because it's part of a different group. So for R3, this remains the same, this remains the same. The identity group will change to 200. I can even keep the group name, the name over here the same. The identity group needs to be different. And the rest is same. Copy for R3. And it should register. Complete. So if I go to R5 and I do show crypto GDOI KS members, you will notice for group ID 100, I have one member, which is 10.10.10.1. For group 200, this is the member for cast A and cast B. Now, what do I need to do for the VRF one, which is R2? So this was for this guy. Key server was this guy, and now where's the GM? Copy this for right now. GM VRF aware. So now your knowledge that I was talking about in terms of VRF aware VPN comes in handy. Here I will not have this. This is where I have those 3 steps. You guys remember? A, ISACAMP policy, done. B is the keyring, because this will not work. So how do I create the keyring? Crypto keyring. Let's call it cost A, VRF cost A. Pre-shared key address 1045.45.5, and the key is Cisco 123. And then the third thing is the ISACAMP profile. Crypto ISACAMP profile, let's call it cost A, just keep it simple. Match identity address 1045.45.5, 255.255.255.255, and the VRF is cost A, VRF is cost A, and the keyring is, call it cost A. Just keep it the same so it becomes easier. So I don't need this key over here, instead I have this. These three steps. Step 2 is this guy, 100, that's fine because I'm doing it for cost A. 1045.45 is fine. Crypto map is also good. The only thing is, with the crypto map, I need to now do what? Apply the ISACAMP profile cost A. And then apply it to the interface, which is F00, which is good. Did I do something with the keyring? Yeah, good. So let's do it now. Let's do it one step at a time because there's a lot of moving parts in this config. Whenever you have that, you should do it slowly. Copy R2. Looks good. Then the crypto map. This one should be okay. Applied, registration complete. So now at this point I should be able to ping 10.1.1.1 from the VRF cost A, ping 10.1.1.1, source 10.2.2.2. Something wrong. Let's check show crypto IPsec SA. Oh yeah, my interesting traffic is wrong. Should be 10.0.0.0 because 10.1, I don't have 10.1, I have 10.2 on this side. So if I want to, I would then need to do the 10.2 to 10.1 as well. So my ACL needs to change over here. I'll just make it 10.0, 0 dot 10.0. Copy. Go to 5. No access. Sure if I have config back. Oh, no access dash list 101 and 102. It's still wrong. This is 10.0.0.255.255.255. This is what I want as my mask over here. Okay, my ACL should be okay now. No. Match addresses are still there. Let's go to 1, clear crypto SA. Registration complete. Show crypto IPsec SA. 10.0.0 is good. This will reset your registration. 10.0 is good. Do ping VRF cust A. There you go. Now you should have encryption over here. That took care of one side. I still have the other side to take care of, which is this guy over here. Copy. This one I don't need to redo because it's the same policy, because it's the same router. So I don't need to do this part. If it was different, I would. This is cust B. Because I'm using the same key, I can keep it the same. The ISACM profile, I'll call it B. Point it to VRF B. Keyring is also called B. GDOI group is for 200. Address is the same. Crypto map. ABC is already applied. So I'll call it DEF because I've used ABC for the first interface. Has to be a different ACL. Crypto map. And for B. And this is going to be applied to the other interface, which is between 2 and 3. Oh, sorry. Even this needs to change. I blew my other one off. Because that was also this thing. So paste it again. Now should be good. Sorry about that. It had to be DEF because my 200 is 100 was what do you call it? ABC. DEF is 200. Now if I go back over here onto R5 and take a look at my registrations, do show crypto GDOI KS members. There you go. I have for customer A 10.1, 10.2. This was the wrong registration that I had. Otherwise, it would not have that. Okay. Eventually, it'll go away. So now, if I go back to R3, should be able to ping 10.2.2.2 from 10.1.1.1. Now what happened? Three to one is now working. 3 to 2 is now working. Show crypto IPsec SA. 10.0A is okay. It's also protected. VRF is A, that's why. And why is that? I must have misconfigured somewhere. Registration is group ABC on the second one. Oh, I know why. The perils of copy and paste. Now it's good. Ping VRF, cust B. There you go. I had applied the wrong one. Over here, let's fix this. This was a problem. And that is the one that you need to be careful about. So to recap, these are the 4 things that I wanted you guys to know. These are the things that you need to be very comfortable with. I'm sure the notes along with the video will help. You need to do it 2-3 times. Should get comfortable with it. It's a very important one. Has been tested in the past and is continuing on getting tested. All right, so let me take some images for you guys. So take a screenshot because I want this to be for your notes. Get VPN-2. All right, so if I go into your folder now, before I do that, let me save this as well. Yep. Get VPN-2. And then there's 3, and this is there. Okay, good. All right. So tomorrow, we're going to be taking a look at VPN using certificates for the CS server as well as IKB2 VPNs. That's the plan for tomorrow. Questions, guys? Now, before you guys go, I need you guys to tell me about your email addresses. I had your email addresses somewhere that I sent this the last time around. When was the last class? It was on the 20th, right? Okay. Guys, help me out. See if your name is not there. Check first, okay? Don't just do it like that. Check your names over here. If it's not there, let me know. Yes, I have. I shared it directly to you as well. Check your junk mail maybe. Software revisions doesn't matter. Anything. You're more concerned about the actual configs rather than the software version. That doesn't matter that much over here. Initial configs as part of the workbook, if you take a look at it at the start, I have put the initial configs. You just need to copy paste them. Okay. All right, this is what I want you guys to check. If it's there, guys, don't give your name, your address again, just for the heck of it. Please see and make sure it's not there, then do it. Isam, you're not there? Okay, got Abid. So that's what I was asking, man. If it's there, I don't want you to put it in again. If it is there twice, well, you're gonna get the same email twice. Okay, check now. I'm gonna send the email right now based on this. Where's yours? Is it better now? I also had this. 1 second. Okay, good. So what I'm going to do is I'm going to send this out based on this email list. I'll also save this email list. Save. All right, done. See you guys tomorrow, same time. Another important class tomorrow regarding the Ike V2 setup. Send me an email, Fahad, regarding that, because it's easier for me to do it when I have it as an email. Oh, where to go? Copy, compose, and tell me if you guys got it. Day 3. Actually, right now I'll send everything except for this. Day 1, and this should be day 2. Initial configs and that. Good. Check, please. See if you guys got it. All right. See you guys tomorrow, same time. I think you are right here. Good night, guys. See you tomorrow.